For over a century, science has told us with absolute certainty that Megalodon, the most terrifying predator ever to rule Earth's oceans, went extinct 3.6 million years ago, a casualty of cooling oceans and shrinking prey, a relic of the Pliocene that exists only in fossils and museum exhibits. But there is another version of this story, one the textbooks do not tell you, one that comes from longline fishermen who refuse to discuss what they have seen on the record. From deep-sea expedition crews who have watched sonar returns they could not explain. From the cold, dark, almost unmapped trenches that cover more of our planet than every continent combined. And the people who pay closest attention to the ocean, the people whose lives depend on knowing what is in the water beneath them, are quietly telling a different story than the one science declared closed. This is the story of why some of the most experienced people on Earth still believe Megalodon never died. The real fossil evidence that has been overlooked. The named witnesses who described enormous sharks long before anyone had heard the word Megalodon. The recent expeditions to the deepest places on the planet that keep finding things nobody expected. And the uncomfortable fact, acknowledged even by mainstream marine biologists, that we have explored less than 5% of the world's oceans and have better maps of Mars than we do of our own sea floor. The official narrative says Megalodon is gone. The deep ocean has not yet agreed. Before we get to what might still be alive down there, you have to understand what Megalodon actually was. Because the version of this animal you know from movies is, if anything, smaller than the real one. The scientific name is Otodus megalodon. The name itself just means big tooth, and the teeth are the reason we know it existed at all. Megalodon teeth are the most common large vertebrate fossil on Earth. They have been found on every continent except Antarctica. They show up in coastal sediments worldwide from roughly 23 million years ago to roughly 3.6 million years ago. 20 million years of unbroken dominance across every ocean on the planet. A standard adult megalodon tooth runs 4 to 5 inches from root to tip. The largest known specimens cross 7 inches. By comparison, the largest great white shark teeth rarely exceed 2.5 inches. The tooth alone tells you what kind of mouth carried it. Body length estimates have shifted over the years as new research has refined the models. The current consensus from named researchers, including Catalina Pimiento at Swansea University and her collaborators, places adult megalodons at 50 to 60 feet long, with the largest specimens possibly reaching 70 feet. A revised body shape study published in 2024 suggests the animal may have been longer and slimmer than older reconstructions implied, which actually makes it more efficient as a long-range deep-water predator, not less. Bite force estimates run from 24,000 to over 40,000 pounds per square inch. That is roughly 10 times the bite force of a great white shark, and substantially more than a Tyrannosaurus rex. This was not a regional predator. This was the global apex of its era. Fossil teeth recovered from coastal sites in North America, South America, Europe, Africa, Asia, and Australia all describe the same animal. Megalodon hunted whales, dolphins, seals, and sea turtles, leaving distinctive bite marks on fossilized whale bones that have been recovered from Maryland to Peru. We have actual physical evidence of Megalodon attacking and killing prey across 20 million years and every ocean basin on Earth. And then, somewhere around 3.6 million years ago, the teeth stopped showing up in the fossil record. After that point, no confirmed Megalodon fossils have been found. The standard explanation is that cooling ocean temperatures during the late Pliocene shrank the warm coastal habitats Megalodon depended on. The slow-moving baleen whales it preferred migrated toward newly cooled polar waters, and competition from newly emerging predators, including early killer whales and ancestral great whites, placed pressure on a species that was already struggling. The extinction is presented in every textbook as scientifically settled. Megalodon is gone. Case closed. But the case has never actually been as closed as the textbooks say. The first crack in the extinction timeline came not from a cryptozoologist, but from one of the most prestigious scientific expeditions in the history of oceanography. In 1875, the British naval research vessel HMS Challenger, on the world's first proper oceanographic survey, was dredging the sea floor in the South Pacific at Station 281, north of the Austral Islands. They were working at a depth of roughly 14,300 feet. What they pulled up in their dredge that day, along with the red clay sediments they were sampling, included 2 large shark teeth. The teeth went into the collections at the Natural History Museum in London, where they sat for decades. In 1959, a zoologist named Vladimir Chernesky published an analysis of those teeth in the journal Nature. Based on the manganese dioxide coating on the surfaces, a coating that accumulates extremely slowly on the sea floor, he estimated their age at roughly 11,000 years. 11,000 years, not 3.6 million. 11,000. If Chernesky's dating was correct, Megalodon had survived for several million years past the date the fossil record claimed it had vanished, and was still alive at a time when modern humans were building the first permanent settlements at sites like Jericho. The Chernesky analysis has been challenged in the decades since. Modern dating techniques applied to similar deep-sea samples have suggested manganese dioxide accumulation rates can vary considerably, and the official scientific position is now that the Challenger teeth probably do come from the Pliocene after all, just preserved unusually well by their deep-sea burial. That is the official position. The teeth themselves are still in the Natural History Museum. Anyone who wants to examine them can do so, and the original Chernesky paper has never been formally retracted. For believers, the Challenger teeth remain the closest thing to physical evidence anyone has produced. For skeptics, they are an interesting but resolved case of early dating error. But the Challenger teeth are not the only thread. In 1918, the Australian naturalist David Stead, who later became one of the foremost authorities on Australian sharks and published the standard reference work Sharks and Rays of Australian Seas in 1963, recorded a story he had been told by experienced lobster fishermen working out of Port Stephens on the New South Wales coast. The fishermen described a shark of enormous size that had passed through their fishing grounds. They described it as ghostly white. They estimated its length at roughly 115 feet, a figure Stead himself acknowledged was almost certainly exaggerated, but the fishermen were experienced. They knew what whales looked like. They knew what every shark species in those waters looked like. And whatever they had seen had been large enough to terrify men who had spent their entire working lives on the ocean. They refused to go back out for days. Stead published the account in his book not because he believed Megalodon was alive in 1918, but because the testimony was credible and the witnesses were people he respected. He treated it as a curiosity. Subsequent generations of cryptid researchers treated it as evidence. The honest read is somewhere in between. Experienced fishermen saw something they could not identify, something larger than any shark they recognized, and the account was credible enough that a respected scientist preserved it in print. What it actually was is not known. What it was not is just as interesting. Not a whale by their own testimony, not any shark they could name. Something else. The accumulating folkloric evidence is fascinating, but the modern story really begins with one specific incident that took place in 2003 and that has never been properly explained. A 9-foot female great white shark was tagged off the coast of Western Australia by researchers tracking shark movement patterns. The tag was an electronic device designed to record depth, water temperature, and location data, and to detach from the shark at a programmed date and float to the surface for recovery. 4 months later, the tag was recovered washed up on a beach roughly 2.5 miles from where it had been deployed. The data it contained was unlike anything the researchers had seen. For 4 months, the tag had recorded normal great white shark behavior. The animal had moved through its expected range. Depth and temperature readings tracked predictably. Then, on a single date, the data showed a sudden and rapid descent. The shark dropped from near the surface to nearly 2,000 feet of depth in a matter of seconds. The water temperature recorded at the tag spiked dramatically, jumping by more than 10 degrees Celsius. And after that point, the tag stopped moving like a swimming shark. The temperature reading remained elevated for days. The depth stayed deep. Then the tag was excreted, slowly returned to the surface, and washed ashore. The interpretation, when researchers tried to reconstruct what had happened, was that the 9-foot great white had been swallowed by something larger, something whose internal body temperature was significantly higher than the surrounding ocean water, something that had then carried the tag inside its digestive system for days before passing it. The case became known among shark researchers as the submarine incident, after the size and behavior of the predator that had apparently consumed a full-grown great white. The Smithsonian Channel produced a documentary on it in 2014 titled Hunt for the Super Predator. The leading mainstream hypothesis was that the great white had been attacked and eaten by an even larger great white, possibly a 15 or 16-foot female. A second hypothesis suggested a killer whale, but neither hypothesis fully explained the temperature data. Great whites are partially warm-bodied, but not to the degree recorded by the tag. Killer whales are warm-blooded mammals, but their digestive temperatures and behaviors do not quite match the pattern either. What does match the pattern, in theory, is a much larger shark with elevated body temperature. The kind of warm-bodied, gigantic predator that recent research from the Proceedings of the National Academy of Sciences in 2023 demonstrated Megalodon almost certainly was. Megalodon, according to that study, maintained a core body temperature roughly 7 degrees Celsius above surrounding seawater, which is exactly the kind of temperature signature the tag recorded. The mainstream scientific community has not endorsed the Megalodon interpretation of the submarine incident. The leading hypothesis remains the larger great white. But the temperature data has never been fully reconciled with that hypothesis, and the case has remained quietly unresolved in the published literature. What everyone agrees on is that something ate a 9-foot great white off the coast of Western Australia in 2003. What ate it has never been definitively identified. If you find this kind of unsolved deep ocean mystery interesting, subscribe. The deep sea keeps producing things that overturn what marine biologists thought they knew, and I cover the cases where the data still has not been reconciled with the official story. Now, before going further into what might still be down there, you have to understand just how vast and unexplored the deep ocean actually is, because this is the part that even mainstream science admits. The Mariana Trench, the deepest point in Earth's oceans, reaches nearly 36,000 feet at Challenger Deep. To put that number in perspective, if you took Mount Everest and dropped it into the Mariana Trench, the peak would still be over a mile underwater. The trench itself stretches over 1,500 miles in length and averages roughly 43 miles across. The total volume of water at trench floor depth is enormous, and the Mariana Trench is only one of dozens of major deep ocean trenches worldwide. The Tonga Trench, the Philippine Trench, the Chile Trench, the Puerto Rico Trench, the Kuril-Kamchatka Trench, the Java Trench, each one a vast deep ocean ecosystem in its own right, each one almost entirely unexplored by human eyes. Before 2019, only 3 people in human history had ever descended to Challenger Deep. Jacques Piccard and Don Walsh in 1960, James Cameron in 2012. Brief visits, limited duration, tiny areas surveyed. Compare that with land. We have mapped every mountain. We have explored every continent. We have satellite photography of Earth's surface at resolutions measured in centimeters. The deep ocean. National Oceanic and Atmospheric Administration itself officially states that more than 80% of the global ocean remains unmapped, unobserved, and unexplored. We have better maps of the surface of Mars than we have of our own seafloor. A creature that lived primarily in the deep trenches, venturing toward the surface only occasionally, could remain effectively invisible to humans for as long as it cared to. We would not find it because we are not, in any meaningful sense, looking. In 2019, the American explorer Victor Vescovo conducted the 5 Deeps expedition, the first systematic project to descend to the deepest point in each of the 5 major oceans. Aboard the submersible DSV limiting factor, Vescovo reached the bottom of the Mariana Trench, the Tonga Trench, the Java Trench, the Puerto Rico Trench, and the Malloy Hole in the Arctic. What the expedition found was extraordinary. New species discovered on virtually every dive, strange invertebrates, unknown fish at depths previously thought to be sterile, plastic pollution at the bottom of the deepest place on Earth, which says something about both our impact and our reach. The expedition expanded what we know about deep-sea biology more in a single year than the previous several decades combined. What the expedition also demonstrated, perhaps more importantly, was just how much remains undiscovered. Every dive produced new species. Every trench revealed new ecosystems. The deep ocean is not an empty wasteland. It is a biological frontier we are only beginning to investigate. And it is into that frontier that the Megalodon survival hypothesis has retreated. Not into the obviously visible parts of the ocean, not into the surface waters where its prey traditionally lived, into the depths where humans almost never go, and where the science can only confirm absence by going there and looking. Here is the part the official narrative has more difficulty with. The reason marine biologists are so confident Megalodon is extinct is that its known biology, warm water, surface waters, large active prey, simply does not fit the deep ocean. Megalodon, as we know it from fossils, could not survive in the cold, dark trenches. The temperature is wrong, the pressure is severe, and, most importantly, the food density is not there. An 80-foot predator needs a steady supply of large prey, and the deep ocean is famously nutrient-poor. As Jack Cooper at Swansea University has noted directly, the idea of Megalodon surviving in the unexplored deep is, in his exact words, complete nonsense based on not a shred of credible evidence. That is the scientific consensus, and it is worth stating clearly. But the believers have a counter-argument that is not as easy to dismiss as it sounds. The counter-argument is that the Megalodon we know from fossils is not necessarily the Megalodon that survived. Evolution does not stop because the cameras have stopped rolling. A population of Megalodon that adapted to deeper, colder water would not look like the Pliocene version we have reconstructed from teeth. It would have changed, possibly substantially. Deep-sea gigantism is a real and documented phenomenon. The giant squid, the giant isopod, the Japanese spider crab, and the big fin squid are all species whose deep-water relatives are dramatically larger than their shallow-water cousins. The cold, the darkness, and the long generations of the deep ocean tend to produce larger animals, not smaller ones. If a population of Megalodon had retreated to the trenches 3 million years ago, the version alive today would not be a fossil. It would be something the fossil record could not predict. That is the hypothesis. It is not science. The evidence does not yet exist to support it. But it is also not as easy to disprove as the mainstream position suggests, because disproving it would require systematically surveying parts of the ocean that have never been surveyed. Absence of evidence in places nobody has looked is not the same as evidence of absence. There are several real precedents for marine species that were considered impossible until they were not. The coelacanth was a lobe-finned fish believed to have gone extinct alongside the non-avian dinosaurs 66 million years ago. It was known only from the fossil record for a century. In 1938, a fishing trawler off the coast of South Africa pulled up a live one. A second species was discovered in 1997 near Indonesia. 2 living species of an animal that had been classified as extinct for 66 million years. The megamouth shark, a 15-foot filter-feeding shark of a previously unknown family, was not discovered until 1976, when one became entangled in the sea anchor of a US Navy research vessel off Hawaii. A 15-foot shark in waters humans have crossed for centuries, completely unknown to science until accidentally discovered 50 years ago. The giant squid, despite centuries of folkloric accounts, was not photographed alive in its natural habitat until 2004. Until that photograph existed, the giant squid was treated by serious scientists as borderline cryptid, a creature whose existence was suspected but not properly documented. These are not edge cases. These are the standard pattern of deep ocean discovery. Animals that should have been findable, animals whose existence was either dismissed or denied, animals that turned out to be real once humans finally went and looked. The argument is not that Megalodon definitely survived. The argument is that the same ocean that hid the coelacanth for 66 million years, that hid the megamouth shark in human shipping lanes until 1976, that hid the giant squid from photographs until 2004, is not necessarily a reliable witness for what it does and does not contain. The honest position is this. The fossil record says Megalodon went extinct 3.6 million years ago. The named scientific consensus, from Cooper and Godfrey and Pimiento and Boesenecke, supports that position firmly. There is no peer-reviewed evidence of survival. The deep trench hypothesis runs against most of what we know about Megalodon's biology and habitat preferences. But the deep ocean is not, in any honest sense, fully searched. The Challenger teeth from 1875 remain in the Natural History Museum. The Chernesky, dating from 1959, has been challenged but never formally overturned. The submarine incident from 2003 has never been fully explained. The Stead account from 1918 still sits in a respected reference book. Every 5 Deeps expedition dive produced new species. New deep-sea sharks are described in the peer-reviewed literature most years. Something is down there. Most of it is not Megalodon. None of it has yet been demonstrated to be Megalodon. But the deep ocean keeps producing surprises, and the people who spend their working lives looking at deep water sonar returns will, off the record, tell you that not everything they detect is yet accounted for. That is the actual frontier, not a confirmed surviving Pliocene apex predator, but an ocean we have not yet finished looking at, holding biology we have not yet finished cataloging, and a fossil shark whose extinction date is supported by strong evidence but whose final disappearance from the planet cannot yet be proven beyond every depth we have failed to visit. The golden age of marine biology is not behind us. It is beginning now. The submersibles are getting better. The sonar is getting sharper. The expeditions are reaching places nobody has been. And in the next 20 years, more of the deep ocean will be properly surveyed than in all of human history before this point. Whatever is actually down there, we are about to find out. Megalodon is almost certainly extinct. The fossil record, the absence of teeth, the named expert testimony, and the basic biology all point firmly in that direction. The official story is probably the true story. But the deep ocean is the largest, oldest, and least understood frontier left on this planet. And until every trench has been mapped, every sonar return has been identified, and every shadow at the edge of a submersible's lights has been investigated, the case is not formally closed. The teeth in the museum in London, the fisherman who never went back out, the tag washed up on the Australian beach, the submersible expeditions that keep finding species nobody predicted. The ocean is keeping at least some of its secrets. Whether one of them is a surviving giant from the Pliocene is a question that, for now, only the deep can answer. If you found this useful, subscribe. The deep ocean is one of the last places on this planet where the answers are not yet in.